Okay, understanding pulleys and inclines and how we can get to apply with the concept of work, power, and energy or conservation of energy. So, say we have got an incline of a certain elevation, okay, got a certain angle here. I'll give the exact angle. Let's say this is 25 degrees. And then we have got a ball which is at this position. Now, this ball starts rolling. Remember, it starts rolling down. Let's say it has got a mass of 2 kg. Now, if I say this is a ball, we might bring in concepts of rotation. So let me just say we have got a box which starts to slide down, and it has got a mass of 2 kg. It starts to slide down. So what will be the velocity is going to have when it reaches the bottom here? Considering that this object is going to be sliding, the only energy it possesses on top there is actually just potential energy, right? It only has potential energy on top. So we'll say potential energy. By the time this box is reaching the bottom, you can see we don't have any height. Okay, on the bottom here you don't have any height. So since you don't have any height, then there's no kinetic energy. I mean, there's no potential energy because kinetic energy, I mean, potential energy should have some height. So potential energy, the whole potential energy is going to be converted into kinetic energy. Now, potential energy in this case is mass, gravity, height, and kinetic energy is half mass, velocity squared. So this will cancel with this, and in that case, gravity we know that is 9.8, the height is 1, that will be equal to half v squared. So we cross multiply, is going to be 2 times 9.8, that is going to be 2, 9.8, that will be equal to v squared also. So to find v, simply square root 2 by 9.8, like that. So that is what is going to give us a velocity which the box is going to be moving with at the bottom. Now say we have got a pulley. And then you have got a certain mass that is tied to this box like this. Let me give to say this mass is 5 kg, and then it comes from rest and suddenly gets to drop a distance of 2 meters. You want to find the velocity with which it's going to drop with this distance. How do you do that? So where it is at this position, it only has potential energy because it's not moving. And when it gets to drop, the potential energy is all going to be converted into kinetic energy. Potential energy is still mgh, kinetic energy is half mv squared. So this is going to, still the masses will cancel out. So this will give us gh, actually with a 2 here being equal to v squared. So meaning v is going to be the square root of 2 multiplied by 9.8 multiplied by the height, which is 2. So that will give us velocity. Now in a case where the pulley itself is also rotating, so let's say this pulley here is also rotating, it has got a certain radius. Now I want to find the velocity with which this mass is going to hit the ground. In such a scenario, this will become different. So This thing is not moving, so it has got potential energy. So the potential energy of this mass down is actually going to be equal to the kinetic energy that it is going to gain. But it will not just gain kinetic energy, this thing will start rotating. So there will also be rotation kinetic energy. This is something that gets to differ here. So potential energy is given by mass times gravity times height. Kinetic energy is half mv squared. Now rotational kinetic energy is half. The equivalent for mass when you are talking about rotational kinetic energy is inertia. And then the equivalent for velocity is angular velocity in rotation terms, because we're talking about something that is rotating. It's not just something that is just standing like that. So that is angular velocity omega. So this will again give us mgh. Now let me differentiate. Remember these small m's. Let me say this one has got a capital M and then this small m. The small m is representing the mass of the block. Capital M is going to represent mass of the pulley itself. Now how do you find moment of inertia? Moment of inertia depends on something. Inertia, if it is a solid disk, that's a half mr squared. If it is a sphere, is it 2 over 5 mr squared? So depending on what they are going to give you, they are going to give you also the moment of inertia. So let's say we are using a solid disk, meaning that the moment of inertia that we are going to use is the 1 over 2 mr squared. So I'm going to say half. Where there is moment of inertia I am going to put half, but the m we are using here is capital M, and then radius squared. Now we're also talking about angular velocity. Angular velocity omega is given by linear velocity divided by radius. So substitute. Now because it's angular velocity squared, meaning to be linear velocity squared divided by radius squared. Okay, sorry for that if it has cut. So I was actually saying angular velocity squared is equal to linear velocity squared divided by radius squared. So now in this you are going to say mgh is going to be equal to half mv squared plus this is going to now give us 1 over 4. This is capital M. R squared will cancel with R squared, so we remain with V squared. Okay, so this will give us mgh being equal to, we can now add like terms. So what I'll do is I can factorize out 1 over 2 V squared plus 1 over 4 V squared. This is common. Now it's tricky the way I've written it. Let me factorize out what's common to say we are going to remain with 1 over 2m plus 1 over 4 capital M. Then we are going to have V squared here. So the small mass is 5 kg multiplied by 9.8. The height which it has fallen is 2. Let's say the big mass is 10 kg. Okay, so that is going to be equal to half. The small mass is 5 plus 1 over 4. The big mass is 10 and then V squared. You can do the multiplication here. 5 times 2 is 10 times 9.8, that is 98, and that is going to be equal to, we have got 1 over 2 multiplied by 5, and then plus 1 over 4 multiplied by 10. This is going to give us 5v squared. So to remain v squared, 98 divided by 5. That will be 19.6. Then we get to square root for us to remain with v. And that is going to give us about 4.43 meters per second. So that will be the velocity that is going to have. So that is the velocity that this object is going to have as it gets to rotate down. If you want to find the angular velocity at which this one is going to be rotating, just substitute in this equation. Angular velocity is linear velocity divided by radius. So just divide by the radius, then you would have found the other one. Is this okay? So let me use also a concept of something that is rotating now on an incline. Let's say we have got a sphere which is down here. It's rotating going up, like going up an incline. And this incline is 30 degrees. Okay, like that. And then the distance of the incline, let's say, is 10 meters. And then this sphere has got a mass of, let's say, 5 kg. Okay, you want to find, what can we even find from here? Because you know that when it reaches the top here, the whole of the potential energy, the whole of the kinetic energy is going to be converted into potential energy to have to start coming back. Now let's say before it finishes, let's say when it reaches here, it has not stopped moving. It has not yet stopped moving. So I want to find the velocity at this position. Now, because here it is rotating, okay, meaning that since it is rotating at this position, let me say it has a velocity, okay, it's not really rotating, but it has got a velocity, meaning that it has got kinetic energy. And as it gets to go up, what is going to be happening? That kinetic energy, now this is going to be a bit of cumbersome. Let me make it in this way. Let me say it's rotating going down so that things will be easier. It's rotating going down like that. So I want now to find the velocity which is going to occupy at this position. So on top where it is, it has got, of course, potential energy because it's not moving. So as it gets to go down, the potential energy is going to be converted into kinetic energy because it's moving. Now remember, it's not only moving, it is also rotating, so it has going to have rotational kinetic energy. So potential energy is mgh, kinetic energy half mv squared, rotational kinetic energy half. Now mass in rotation is inertia, velocity is angular velocity squared. Okay. Then from there, this will be mgh being equal to half mv squared plus 1 over 2. Since this is a sphere, moment of inertia is 2 over 5 mr squared. Okay, so since this is a sphere, moment of inertia is 2 over 5 m r squared. And then where there is angular velocity, we replace with linear velocity divided by radius squared. Sorry, someone called my phone, so the network got to slow like that. But are you able to still follow up?
Yes.
Okay, so the radius here will cancel with the radius here. This mass will cancel with this mass, which will cancel with this mass because it's common, so remain with GH being equal to half V squared plus these two cancel with these two, so remain with 1 over 5 V squared. So this will give us GH being equal to 7 over 10 V squared. So I can also say V squared is equal to 10 over 7 GH. Then V is going to be square root of 10 over 7 GH. Therefore, the velocity of this sphere is going to be square root 10 over 7 G is 9.8. Now, how do you don't know the height in this case. So, you know that sine of the angle theta is given by opposite, which is height, over hypotenuse, which is the distance. So, height is actually distance in theta. So, the distance is 10, sin the angle is 30. That's what we're going to use. So multiply that. We know sin 30 is 1 over 2. 10 times 1 over 2, that will be a 5. So this is 5 times 9.8 times 10 divided by 7. Then the answer we get is square root. So the velocity then is going to be 8.37 meters per second. That is going to be the velocity in this case.